discussion is a new chapter in Unit 3, which is Uncertainty Measure, Probability Theory. Well, all the previous topics have created knowledge base which is assumed to have accurate information. However, um, in real world situations, not every information is accurate. There is some degree of uncertainty associated with the knowledge or the information. So what we have to do is we have to incorporate uncertainty in our knowledge base as well as while we are deriving new conclusions. To do that, probability theory is very useful because it is one of the methods available for handling uncertain information. The other methods are fuzzy logic and temporal logic. Essentially, to handle uncertainty, the methods are probability theory, fuzzy logic, model and temporal logic. In this chapter, we will discuss about probability theory, which is designed to estimate the degree of uncertainty. For instance, if I tell you today it will rain, there is an element of uncertainty involved in that. When we don't consider uncertainty, we say that for sure it rains, and in case if it does not rain, then your prediction has evaluated to be false. If you instead of saying for sure or 100% it rains, if you associate a kind of probability to that, if you say that 0.7% or 70% chances are there for raining, and 30% it may not rain also. So here what you are trying to do is you are not trying to be very accurate, about the information, rather you are giving a probability score to your evaluation, whether it is yes or no. To yes also you are specifying a probability, and to no also, and then if, your conclusions also will have this uncertain factor associated. The important concepts which we will cover in probability theory are Bayesian belief network, certainty factor theory, and Dempster-Shafer theory. All have been discussed in this chapter. Uh, Additionally, we will look at how probability element can be added to a rule-based expert system. Let us begin the concept of probability theory. Before delving deeper into what it is, we need to know um, its definition and its axioms. So here the term probability is defined as a way of turning an opinion or an expectation into a number lying between 0 and 1. As you know, probability value lies between 0 and 1. It reflects the likelihood of an event. If the value is 0.9, it is more likely that that particular event occurs. And if it is 0.1 probability, it is very less likely that event occurs. So first point is that probability lies between 0 and 1, and it reflects the likelihood of an event or a chance that a particular event will occur. Assuming a set S, which is called as a sample space, consisting of independent events representing all possible outcomes of a random experiment. If you have a dice, and if you throw a dice, the sample space is between 1 and 6, because you can get a dice showing the the surface of dice showing 1 or 2 or 3 and so on and up to 6. That is a sample space. And random experiment, uh, just throwing a dice is a random experiment, and whatever value you get is a random value. And this um, sample space, if it is non-empty, it is called as event. An empty set is called an impossible event, whereas S is called a let me tell you. S is called a sure event. Here the terminology given is a sure event. S is called a sure event, and an empty set is called an impossible event. If you denote a probability of an event A by P of A, then it is defined as P of A equal to number of outcomes favorable to A over total number of possible outcomes. And probabilities of all events A1, A2 up to An must sum up to certainty, that is probability of A1 plus probability of A2 and so on up to probability of A sub n is equal to 1. So an impossible event has a probability 0 and a certain event has a probability 1. An event which does not likely to happen has a probability of 0. that is impossible, and a certain event has a probability 1 which happens for sure. If you consider, for example, our current scenario, our lockdown period, what is the probability that we get exams in May, or what is the probability that we get exams during June? And what we can say from the experience that um, it is an impossible event which has a probability 0 for the exams to be conducted during May. And it is a certain event that a probability of exams being conducted during July is 1. You know, certainly exams have to be conducted, and the expectation, the most likely month may be July, whereas 0.5% or 0.6% there is a chance that during June also it may happen. So like that probability will be associated. The example given is tossing a coin. So when you toss coins, the probability of throwing two successive heads with a fair coin is found to be 0.25. How it is possible? Because of the total number of possible outcomes are head head, head tail, tail head, and tail tail. It's like throwing a fair coin twice successively. A fair coin you are throwing twice. Um, you know, one after the other. So there are chances that both the times you get head and both the times you get tail, or you get head tail or tail head. So the probability is 1 by 4, which is equal to 0.25, because the sample space here is 4 events, and number of outcomes favorable to A. What is the event we are looking for? That getting HH. Both you should get heads in two successive uh, coin throwing activity or event. So one head head occurring is 1 by total number of possible outcomes. Therefore 1 by 4 is 0.25. And axioms of probability, I think you remember. Probability of A is greater or equal to 0, and probability of S means sample space should be equal to 1, because probability of A1 plus probability of A2 and so on, probability of AN together should be equal to 1. Probability of A dash is equals to 1 minus probability of A. These are some axioms. Probability of A union B equal to probability of A plus probability of B if events A and B are mutually exclusive. If events are not mutually exclusive, then it is equal to probability of A plus P of B minus P of A and B. Okay, so this the second rule, which is probability P of A union B when A and B are not mutually exclusive, is called addition rule of probability. And the proof of this axiom is given below. Here you can see that we can easily see that A union B is equals to A union A complement and A union B, which is equal to A union A complement and B. So therefore what happens here is you take this P of A union B equal to P of A union A complement and B. So what you are doing in this, as A and A complement and B are mutually exclusive, you are writing it as P of A plus P of A complement and AB because they are mutually exclusive. They are two different events. And here uh, P of A plus P of A complement and B plus P of A and B minus P of A and B. This you can add and subtract. This operation you can perform without uh, changing the meaning of this. And then P of A plus P of B minus P of A and B because of this rule. P of B equal to P of A and A complement and B plus P of A and B. If you substitute this for P of B, then you get P of A plus P of B minus P of A and B. So if you look at here, this part, this whole part, P of A and A complement and B plus P of A and B, which is equal to P of B, because here you have A and A complement, so you get P of B here, and this remains as it is. So it is proved that P of A union B is equal to P of A plus P of B minus P of A and B for non-mutually exclusive um, events. Um, in general, events are mutually exclusive, and then we can write like this: P of A union A1 is the first event, A2 is the second event, and so on up to AN. And this can be written as, you can just separate their probabilities and you can join them by using plus operator. So P of A1 plus P of A2 and so on up to P of AN. Another concept is joint probability. It is defined as probability of occurrence of two independent events in conjunction. Joint probability means, two independent event occurs together. For instance, uh, here it is given that P of probability of A and B. There is a probability of A, one event, another event is probability of B, another event. So what you are doing, you are so how can you write these two events as a joint probability? By using probability of A, this is um, asterisk, it is like into probability of B. Two events are said to be independent if they occur if the occurrence of one event does not affect the probability of occurrence of the other. You know about it, and you know that that asterisk there is like into means multiplication. For instance, two different events like you having you having an exam and you having your sister's marriage. So these two are two independent events. Actually, they are not um, related. But then, if you um, join them by using joint probability, then you have to perform a multiplication operation of P of A into P of B. And here tossing example given here is tossing of two fair coins separately. The probability of getting H on tossing the first coin is denoted by P of A equal to 0.5, because now you are considering that you can get H or you can get T, heads or tails. So 1 by 2 is equal to 0.5, and the probability of getting a head on tossing the second coin is denoted by P of B, which is also equal to 0.5 because it can be 1 by 2. So the probability of getting heads on both the coins is called joint probability and is represented as P of A and B, which is calculated as P of A into B. So in the first case it is 0.5, in the second case also it is 0.5. So if when you multiply both you get 0.25. Probability of getting head on tossing one or both coins can be calculated as the union of the probabilities. So this is done by using P of A or B, and P of A or B is uh, denoted by uh, P of A plus P of B minus P of A into B. When you substitute and when you solve this, you get this equation. And when you do this, get this one, it is P of A 0.5, P of B 0.5, and P of A into B is 0.25. So totally you get 0.75. And this is also another example of joint probability distribution. Probability of A and B is 0.2. Probability of A and B complement is 0.65. This one. Probability of A complement and B is 0.12. And P of A complement and B complement is 0.03. So you can compute P of A and P of B by using this formula, P of A and B plus P of A and B complement, which is equal to 0.2 plus 0.65, which is equal to 0.85. This is the individual probability of A. Here you have joint probability of A and B, and after you solve this equation you get individual probability of B. So this one 0.2 is A and B plus 0.12 is A complement and B. So B probability will be equal to 0.32. So if you perform sum of this two values, you get A probability of A, and if you perform sum of these two, you get probability of B. This. Next, we can compute probability of any logical combination in the following manner. We know the axioms and we know the values. If you just go on computing, then you can get values of different combinations. Here you are trying to find the probability of A or B. For that we know P of A plus P of B minus P of A and B, which is equal to P of A and B plus P of A and B complement plus B of A and B plus P of A complement and B minus P of A and B. So when you write like this, you get A and B, you get A and B complement, and you get A complement and B. So you get these three values from this distribution. It is like this: A is this and B is this. When you sum all, you get A or B, which is equal to 0.97. 3, this 1, 2 and 3. Uh, alternatively, we can calculate probability of A or B as follows. If you say 1 minus P of A or B whole complement, even then you get this same. Instead of summing, instead of performing a sum of A and B, if you perform a difference of their complement, even then you get this 1 minus P of A complement and B complement. A complement and B complement is this one, this part. This is A complement and B complement. So if you say 1 minus, because if you remember, the sum of all these probability values is equal to 1. It is equal to 1. If you perform sum of these three, or if you say 1 minus this, it gives the same result. So here you are getting 1 minus 0.03, which is equal to 0.97, which is equal to getting a value which is obtained by summing. So I hope that this is clear. Next is conditional probability. Conditional probability is when one event, uh, the occurrence of one event is dependent on the occurrence of another event. For instance, again, if you take a normal example, you coming to your place no, you coming to college is subjected to lockdown uh, being lifted. If lockdown is lifted, then you can come to college. If this is the um, event occurrence, sequence, then you know that coming to college is dependent on lockdown being lifted. If lockdown is not lifted, you cannot come to college. So this is conditional probability, where two events are related and the occurrence of one event causes the occurrence of another event. So it is defined as probability of the occurrence of event H, which is hypothesis, provided an event E evidence is known to have occurred. If evidence has occurred, if evidence E occurs before, then you can conclude that there is a probability of occurrence of event H, which is hypothesis. If evidence occurs, then hypothesis occurs. So the equation is P of H given E. P of H means hypothesis given E evidence is equal to uh, number of events favorable to H which are also favorable to E over the number of events favorable to E. The number of events, which are related to both H and E over number of events which are related only to E. This can be written as P of H and E over P of E. It is very uh, obvious that when P of E equal to 0, when there is zero evidence, then this rule cannot be used, because if there is a zero chance of E occurring, then H also will not occur, because if E does not occur. Let us look at an proof. So here, probability of hypothesis given evidence. We know that probability of H and E over P of E is given. Then what you can write, this can be written as P of H into P of E. This can be written as this and over this, which is equal to P of H. So if they both get cancelled, then what will be left over? Only P of H. So similarly, okay. So likewise, we can also prove for probability of E given H, evidence given hypothesis, will be equal to evidence. Look at here, this whatever is used as um, you know event before this given symbol only will be the output of this. Let us look at an example. Here probability of a person chosen at random being illiterate is given to be 0.40, and the probability of any person chosen at random having age greater than 60 as 0.005. So you have to find the probability of the fact that a person chosen at random of age greater than 60 years is literate. So how can you solve here? This is x is literate and the age of x is greater than 60. How can you write this x is literate? You are splitting this into x is literate multiplied by age of x greater than 60. So x is literate is 0.4 and age of x greater than 60 is 0.005, which is equal to 0.002. So the probability of a person chosen at random both literate and age greater than 60 is 0.002. Then the probability of a person chosen at random having age greater than 60 and literate is calculated using the conditional formula. Okay, this is and when both, if both a person is literate and age is greater than 60 is this. Here we have to find conditional probability. Conditional probability means x is literate given age of x is greater than 60. So here we got the probability of both to be 0.002 over 0.005 is this, which is equal to 0.4. X is literate given the age of x greater than 60, the probability is 0.4. I hope that it is clear. So next one is okay, there is a joint probability distribution graph given. Here in this we are considering that the probability of some event today such as sun is bright today as P of sunny today is 0.6 and probability of same event tomorrow sunny tomorrow given sunny today is 0.8, provided today the sun is bright. It should be noted that if sun is bright today, then the probability of sun being bright tomorrow is high, and these two events are not independent. So we have to compute all possible joint probabilities of these two variables, and to do so, let us represent A for sun is bright today and B for sun will be bright tomorrow, and we get four combinations that is shown in 9.1. So look at here, A, What is A? Sun is bright today. What is B? Sun will be bright tomorrow. So sun is bright today is zero point 0.6, and sun is not bright today, which is equal to 1 minus 0.6, equal to 0.4. I'll be back.
హాయ్ జాను.
వింటున్నావా?
ఇందాక అనుకుంటున్నా ఇంత మాట్లాడదాం మేడం మ్యూట్ అయిన కానికి అని, కానీ ఇంతలో మహేష్ ఆడేయండు.
నేను కూడా అదే చూస్తున్నా. పాపం.
ఏం చేస్తున్నావు మరి? నాకు హెడేక్ అనిపిస్తుంది కొంచెం ఈరోజు.
తినేసి కూర్చున్నాను.
మధ్యాహ్నం క్లాస్కి వస్తావా మరి? 1:30
ఎప్పుడు?
క్లాస్ సార్ది.
వెబా చూస్తా అప్పటి వరకు. అసలు అందులో బ్యాటరీ ఛార్జింగ్ లేదు తెలుసా, 2% ఉంది.
బై బై, నేను ఉంటా
బై బై.
క్లాస్.
Okay, students, I'm back. So we are discussing this problem. So a P of A, which is sun is bright today, is 0.6, and sun is not bright today is 0.4, and tomorrow sun will be bright tomorrow is B. P of B. P of B means now you have to here find P. B given A, B given A and not B given A, and B given not A and not B given not A. If you put the values, then you will get this. A B given A means tomorrow will be sunny. Given today is sunny is 0.48. Tomorrow is not sunny. Given today is sunny is 0.12. Tomorrow is sunny. Given today is not sunny is 0.24. Tomorrow is not sunny. Given today is not sunny is 0.16. Students, so tomorrow we will study Bayes theorem. So now tomorrow we will study Bayes theorem and extending Bayes theorem. And Bayes theorem topic we will look at tomorrow. So I will stop the class today. I hope it is clear. Bye bye.